an introduction to variability. Mass customization is the offspring of variability, postponement, and cross-training. I'm going to briefly talk about these three concepts in 3 talks. Indeed, in more than 3 talks. First, I will talk about variability, then about postponement, and I provide some statistics and simulation practices. And finally, I'll talk about cross-training and make the discussion combined with a simulation example and a linear programming example. Suppose you just had a child. In the evening, a friend come to visit you. She provide you with 2 alternatives. The first alternative is to give you $100. The second alternative is to buy you an offer from piggy bank, which will be matured in 60 years. Piggy bank offers every morning they put $100 in your kid's account. By 6 p.m., they take that $100 out, and then at midnight, they look at the balance and they add 6% interest. This process continues every day for 60 years. At maturation, your kid can go to piggy bank and withdraw what she has. Which one do you choose? Getting $100 today or go through this process? For the sake of simplicity, let's assume there is no inflation. Out of these 2 alternatives, I think you will select this one and get the $100. Suppose they make a change in this offer. Every day they put down $100. At 6 p.m., they flip a coin. If it is head, they do nothing. If it is tail, they take out $200. It is unbiased. Coin and probability of head and tail are exactly the same, and they are 50%. Therefore, 0.5 times 0 plus 0.5 times 200 is 100, an average of 100. Again, every morning they deposit $100. At 6 p.m. flip a coin. Either they take out $200 or 0, an average of 100. At midnight, they compute the interest rate and add it to the balance. What do you do? Let's see what will happen. I will go to this Excel sheet and I open it. Every morning, they deposit $100. In the evening, rand between 0 and 1. Therefore, they flip a coin. And it comes out either 0 or 1. Multiply it, and we will copy it down. If it is 0, nothing is withdrawn. If it is 1, $200 is taken out. The average is 100. Let's see what will happen to the balance. At the end of day 0, you had $0. Then you collected $100 in the morning, and in the evening, you take this much out. Don't forget, the balance cannot be negative. Therefore, if you have $100 in your account, they cannot take out $200. This summation of the 2 and minus the other one cannot be less than 0. Maximum of 0 and this. If it is positive, they write it over there. If it is negative, they need to put 0 money if you don't have it in your account. Let's see on average how much money do you have in your account, equal to average all the way down to here and lock it. Enter and copy it down. On average, you have $10,000 in your account. This is the graph, and it shows the balance of your account. Look at your balance. Here, each year, on average, you have had $9,000. Then you come here, equal to future value. Future value rate is 6% in this bank. Number of periods is 60 years. Each year you put nothing. At the beginning you put the average that you have. It's the average you have. And that would be future value. This numbers comes out negative, that is conventions inside Excel for present value and future value. We put a negative sign here. So if we look at this graph, in one of these replications, on average you have had about $5,000 in your account and your future value is $174,000. In another example, you have $8,000 and future value is $283,000. So average is here, future value is here, and we can repeat the experiment. $7,000, $2,000, $4,000 with future value of $143,000, future value of $112,000, $381,000, $259,000. That is the difference between a deterministic word and a probabilistic word. Let's do a second example. Suppose demand for a product has an average of 3 per hour. Demand for a service has an average of 3 per hour. This can be a service system where we cannot produce to put things in inventory, or it could be a production system which is fully pooled and we do not produce unless there is a demand. Suppose capacity is also 3 per hour, but it is not deterministic. Suppose demand is uniformly distributed, rand between 1 and 5. Demand has an average of 3, but it is distributed between 1 and 5. And I copied here. Capacity also has an average of 3, but it is not deterministic. It is distributed between 1 and 5. Suppose we start with 0 inventory. In day 1 equal to inventory of yesterday plus demand of today minus production of today, that is what is left in the waiting line. But what is left in the waiting line cannot be negative. If demand is 1 and capacity is 5, we cannot produce 5, one of them to satisfy the demand and put 4 of them in the line for tomorrow. No, if demand is not there, that capacity is gone. Therefore, what is left in front of this machine, what is the balance, is maximum of this number. But if this number is negative, it cannot go below 0. Now let's look at this graph. This is the graph of balance in front of the machine. If utilization is equal to 1, if capacity is equal to demand, we see such a huge waiting line. You see, in this instance, in some points, we have had 160 customers waiting. Of course, in some times also no one was there, but on average, we have had about 60 customers waiting, 40 customers on average, 60 customers on average, customers on average, to say more than 200 customers in the line. That is why systems cannot produce at capacity. This was my first talk on variability. I will have one or more talks on variability. Then I will have a talk on postponement, and then one or two talk on cross-training. And all of these are targeted towards possibilities for mass customization. Thank you for attending this session.